Namaste one and all. I am Sonal Priya from first year CBChet. I want to discuss about the topic called Diborane, B2H6. Diborane. Diborane is a compound that consists of boron and hydrogen atoms, and it has the molecular formula as B2H6. The substance diborane is highly unstable at the room temperature, and it has a sweet odor. Generally, the compounds consisting of boron and hydrogen are called as boranes. Diborane is one of the simple boron hydrides. Diborane is originated from the nidoborane. The other names for the diborane are boroethane and diboron hexahydride. Physical properties. Coming to physical properties of diborane, diborane is a colorless compound. It has a sweet odor. Diborane is toxic or poisonous. It has a lower thermal stability. It has a stability at the lower temperatures. It is stable at the low temperatures, and at high temperatures B2H6, the diborane is converted into the higher boranes, and diborane is highly reactive. The boiling point of diborane is 180 degrees centigrade. Chemical properties. Diborane undergoes a reaction on heating. On heating, diborane undergoes decomposition reaction. When it is heated at the high temperatures more than 100 degrees centigrade, it becomes higher boranes and on liberating the hydrogen. On reaction with excess oxygen, when diborane is reacted with excess oxygen, boraxin, a compound, is formed. On reaction with the water, when diborane is reacted with 6 moles of water, 2 moles of boric acid is formed on liberating 6 moles of hydrogen gas. The reactions are mentioned here. And preparation of the diborane. Diborane can be prepared from different methods. I have those two methods, and from boron trichloride. When boron trichloride is treated with 6 moles of hydrogen in the presence of copper or zinc, it forms the diborane. And from sulfuric acid, when the sodium borohydride is treated with sulfuric acid, the diborane is formed. So we get the diborane from these two methods. Structure of diborane. Generally, the molecular formula of diborane is very similar to the ethane, but the structure of diborane is not similar to ethane because diborane is the electron deficient molecule. Here, diborane B2H6, it is very similar to the ethane C2H6. In ethane, the total number of valence electrons in both carbon and hydrogen are 14, whereas the total number of valence electrons in the boron and hydrogen in diborane are 12. So, due to the loss of 2 electrons, the structure of diborane is different from the ethane. We can prove the difference from some evidences. First method is called as electron diffraction method. From the electron diffraction method, we can say that by seeing the structure, there are 2 kinds of 3 planes are formed. There are 2 B2H planes and 1 H2 plane. We can see the planes from this structure, and we know that there is no bond between 2 boron atoms. In this molecule, each of the boron atom is bonded with 2 hydrogen atoms outside each, and also the boron atoms are held together by 2 hydrogen atoms. The hydrogen atoms which combines both the boron are bridged hydrogens, and the outside hydrogens are called as terminal hydrogens. From the electron diffraction method, we can know that diborane structure forms 2 kinds of planes, and those are 2BH2 and 1H2. From the rotation or IR spectroscopy, we know that there is no bond between the boron atoms, and the hydrogens between the borons connect them together. The 2 hydrogens connecting borons together are called as bridged hydrogens, and the hydrogens surrounding the boron atoms are called as terminal hydrogens. These bridged hydrogens comes together and comes closer and make some repulsions, and they bend together to form the banana bonds. The banana bond are also called as T bond. Only the terminal bonds always participate in the chemical reactions, whereas the bridged hydrogens cannot participate in the reactions. Here it forms the 3 centered and 2 electrons. There are 2 There are 2 3-centered and 2 electrons, and 4 2-centered and 2 electrons here from this structure. And whereas from the structure of diborane, we can know the bond lengths of the following atoms. So the bond length of the boron and bridged hydrogen is 1.33 angstroms, and the bond length of the boron and terminal hydrogen is 1.19 angstrom. The bond length of the boron is 1.77 angstrom. The bond angle of bridged hydrogen and a bridged hydrogen is 97 degrees. The bond angle of the terminal hydrogen to terminal hydrogen is 121.1 degrees centigrade. And this is the structure and structure of the diborane. Thank you.